Hi guys, so this video is on factoring completely. This is basically taking all of our factoring methods that we've learned, GCF, binomial with DOPS, trinomial with factoring that, and putting it all together. So we are going to look at some problems and we're going to think about ways we can factor it that make it completely factored, and that means like the most expanded form. All right, so what is factoring completely? So there's three methods that we've learned. Like I just mentioned, we have our GCF, DOPS, and factoring a trinomial. So how do I know when to do what? Well, the first thing you want to ask yourself is it a binomial or is it a trinomial? All right, and then we're going to look for DOPS or is it factorable with a trinomial. So I see this first example below and I see that it is a trinomial. All right, so I definitely am going to do that. All right, but let's say I went straight into trinomial, because that's a lot of habit that we have. We go straight into that. And if I do that, I get 4 times 32, which gives me 128. Now, I noticed some of you doing this the other day, and you're like, oh my God, well, there's so many factors for 128. It's going to take me forever to list them all out. How about if I can make the number smaller? So I can make the number smaller if I am working with a GCF. So when I'm looking at these problems, before I go into factoring a trinomial, I want to ask myself, is there a GCF? Okay, so I scan. Is there something that I can divide each one of these by? And yes, I can divide them by 4. So if I divide them by 4 and take out a GCF, remember when we do our GCF, it goes on the outside, and what's left over goes on the inside. So x squared (6x) and 8. So now I have a trinomial still, but my trinomial is much smaller. Our numbers are x squared and 8. That's much easier to work with. Okay, so I'm now going to factor that. And when I'm factoring the trinomial, I'm only going to focus on this inside part until the very end. All right, so our GCF is great. It's just going to hang out to the side. So now I'm going to go ahead and factor this trinomial using my process. So I'm going to multiply these and create a product. Hi guys, so this video is on factoring completely. Basically what we're going to do now is we're going to take all three methods that we learned, GCF, trinomial, and DOPS, and put it together to form one problem essentially. So, the most obvious thing to look for is it a binomial? If it is, we check for DOPS. If it's a trinomial, we look, can we factor it using our product sum? Okay, so the other thing that we did in the beginning, which we kind of forget about, is GCF. And I have that at the top for a special reason. So let's take a look at this first example. Now, I don't want you to write this just yet, but let's take a look at it. I see that it's a trinomial, and it's pretty obvious to me that it's a trinomial because it has 3 terms. Let's say I were to go automatically into factoring a trinomial and do my factor sum table. Sorry, product sum. If I were to do that, 4 times 32, that's 128. And while I can do it this way, it is not wrong to do it this way, it would take me a while to list my factors of 128. All right? So something that helps me and makes life a little bit easier is to make the numbers smaller. And in order to do that, I need to start by scanning for a GCF. Okay? So let's look at our original problem. Is there a possible GCF that I can divide out into all 3 numbers? Yes, there is. What is it? That's 4. So what I'm going to do is I'm going to divide them all. Remember, when we divide our GCF, it goes on the outside, and what's left over goes inside my parentheses. So in my inside, I'm going to be left with x squared minus 6x plus 8. Now let's take a look at the trinomial. So now when I see my trinomial, it is much smaller and much easier to work with. So now I did GCF, and now I'm going to go ahead and I'm going to factor a trinomial. All right, but when I'm factoring the trinomial, I'm only going to focus on what's on the inside. So I'm only going to focus on x squared minus 6x plus 8. And I'm going to highlight my GCF because I don't want to forget about it because we're going to need that at the end. So with my smaller trinomial, I can now go ahead and do my product sum. And I'm going to get smaller numbers, so it's going to be easier to work with. So now I only get 8x squared and negative 6x. That's much easier than working with 128 and negative 24. All right, so go ahead and list the factors. And I see that my sum is negative, which means I'm going to need my negative factors. Okay. And now I'm going to take the sum. So I'm going to change all my multiplications to addition. And I know it has to be a negative 6x, so I'm not even going to bother with the first two. This gets me negative 9x, and this one gets me negative 6. So those are my winners. All right, so I make my box. Ooh. And a lot of us are still confused about what to put in the box, so I'm going to go through that. Our first term, the one that we circled with our product sum, that's going to go in my first box. Our last term, which we also circled during our product sum, is going to go in my last box. Now the two middle boxes are coming from my winners in my table. So I'm going to write negative 2x and negative 4x. Okay, so I'm no longer writing the 6x. That's what we expanded with the negative 2x and the negative 4x. Okay, great. So now I see my reverse box, and I'm just going to go ahead and do that. So x times x gets me x squared. It's always an easy one. And then negative 2 would get me negative 2x, and negative 4 would get me negative 4x. So I'm going to go ahead and write those in my parentheses. I've noticed a lot of us are forgetting to do this final step. What is our answer? Our answer is x minus 2 and x minus 4. But remember, when you are factoring completely, you need to think back to what did you take out in the beginning. I have to put that back into my answer. So we took out a GCF. So I need to put my GCF back into my answer. So my final answer is 4 parentheses x minus 2 parentheses x minus 4. And now that is factored completely. All right, so that is my answer. Let's label that. Answer. Some of us are getting confused on what the answer is versus what the check is. So my answer is that factored form. It's all split up. How do I check? I'm going to revert back to checking for equivalence by substituting, just so we can see the difference. So here's my original. I'm going to go ahead and substitute for 1. And I'm just going to go ahead and multiply that out. Okay, and that gives me 34. Now I'm going to check my answer. Again, I'm going to substitute for 1. Oh, I made a mistake. Because this gets me 12. And those are not equivalent. So let me check back. So I scanned. Did I write my original right? Nope. This is my mistake. So my original is supposed to be 24x. So this guy should be 24 and 24. 4 minus 24 is negative 20. Negative 20 plus 32 is 12. Great. So now I see that they are equivalent, which means they're correct, which means I factored correctly. All right. Let's keep it moving. So I'm going to do this one a little bit faster. So I see that this is a binomial. I can think of DOPS. Does it work? Do I have a subtraction and 2 squareds? Yes, I do. So DOPS is going to work. But is there something else? So think back to what we did in the beginning, and I want to ask myself, is there a GCF? Can I make these numbers smaller? And there is. What is the GCF? What can I divide both numbers by? 9. So I'm going to go ahead and do that. Again, if you forget to do that, you're not going to be wrong. You're just going to have to take your GCF out at the end of the problem. So now my problem looks like this. And now I can go ahead and do DOPS. So I'm going to split this up and use my shortcut, x times x, 2 times 2. And I can only do this with DOPS. So I bring down my 9. And then from my inside parentheses, it's going to be x plus 2 and x minus 2. And that is my final answer. Okay, let's quickly check. 9x squared minus 36. 9, x plus 2, x minus 2. I'm going to use 0 for this one. So I'm going to replace this with 0, this with 0, this with 0. And that goes away. I'm left with negative 36. This one I'm left with 2 and negative 2. 9 times 2 is 18, times negative 2 is also negative 36. They're the same. I am good. All right, as always, if you have any questions, please put them at the end of this video. Thanks.